We're beginning here, we're talking about definitions of functions. So to begin with is relations, a set of ordered pairs. For example, like 3, 5, 2, negative 7, 1, 1. And these are just examples of relations. They relate one value to another. Domain is a set of first components of each ordered pair, and in this case, we're looking at, it's the x values. So we'd have, x equals 3, 2, and 1. Range is a set of second components of each ordered pair. So in this case, the y values, we have 5, negative 7, and 1. So different names of the domain, input values, and independent variables. Different names of the range would be output values, sorry about that, and dependent variables. So here are some examples, though. We have specifically, though, a function is a relation. So all functions are relations, but not all relations are functions. Just like all Labrador retrievers are dogs, but not all dogs are Labrador retrievers. So a function is a relation in which each possible input leads to exactly one output. So I have this graphic here to address that. So here's a relation. This is a relation that is a function. So P goes to one thing, Q goes to one thing, and R goes to one thing. Now Q and R go to the same thing. That's okay. But P, Q, and R only have one thing they go to. This next one's also a function. P goes to X, Q goes to Y, and R goes to Z. Everything's fine. Now this last one's not, because while P goes to one thing, Q goes to two different things. So Q has two partners there. That's not a function. How to determine if a relation is a function? Identify the input values. Identify the output values. If each input value leads to only one output value, the relationship is a function. If any input value leads to two or more outputs, the relationship is not a function. There's a typo there. Is not. Look at that, fixing it real time. A function. Okay. Save. So moving on here, example 1, the table shows the 5 greatest baseball players of all time in order of rank. We have Babe Ruth, Willie Mays, Ty Cobb, Walter Johnson, and Hank Aaron. So first, second, third, fourth, fifth. So is the rank a function of the player's name? So does the rank lead to a specific player? Yes. So first place is Babe Ruth. Second place is Willie Mays. Then Ty Cobb. Then Walter Johnson. Then Hank Aaron. Is the player name a function? Yes, because the name leads to a rank. Now, if we were to have two people tied for the same rank, then it wouldn't. But in this case, each rank only has one player. So the answer is yes and yes. Now we have function notation. This is important to understand. Different types of function notation. You could write it out. H is f of a. So we name the function f. H is a function of age. H equals f of a. Means the same thing. We use parentheses to indicate the function input. So the variable of the function is a. This does not mean f times a. It means f is a function of a. That's the variable that's going to be doing stuff, or stuff happens to it. Or just f of a. This is pretty common what we go with here. F of a. The function f evaluated with this variable a, this stuff happens to it. So standard function notation, the notation y equals f of x defines a function named f. This is read y is a function of x. The letter x represents the input value or the independent variable. The letter y or f of x represents the output value or the dependent variable. So example 2. Use the function notation, let me send this a little better, to represent a function whose input is the name of a month and the output is the number of days in the month. So for this function, if we said d equals days, and m equals months, our function could look something like this. D equals f of m. So the number of days is a function of the month. For example, 30 days is a function of June. Or 31 days is the function of, pick one, March. I'm going to skip trying to nail down February because that one has two different outputs, which would make it not a function. Okay, example 3. You hear my cat meowing. Sorry about that if that bothers you. A function n equals f of y gives the number of firefighters n in a town in year y. What does f of 2015 equals 135 represent? That means in the year 2015, there were 135 firefighters. In the town. Okay. So note y of x and y are generally synonymous and means that y is a function of x, where x is the independent variable and y is the dependent variable. Okay, and then this last part here for this video, given a table of input and output values, how to determine where a table represents a function. Identify the input and output values. Check to see if each input value is paired with only one output value. If so, the table represents a function. So we have these three tables, A, B, C. So notice that 2 goes to 1, 5 goes to 3, and 9 goes to 6. So each thing has one partner, so this is a function. Then we have -2 goes to 5. 0 goes to 1, 3 goes to 5. These are the same thing, obviously. But 2 only goes to one thing, and 3 only goes to one thing, so it's okay that they both go to the same thing. So that 2 is a function. And then part C, table C. So here we have 1 goes to -2, but then 7 goes to two different things. So these are the same, and they're going to two different values. So this is not a function. It's just a relation. They're all relations, but the A and B are also functions. Okay, that's going to be it for this video. The next one we're going to pick up with how to evaluate the formula for a function given a value.